Hi everyone, my name is Max Vansel,
I'm Ronnie Mattini.
and today we are going to go over a bit about the history of computer vision and autonomous vehicles for ECE 4881 Robot Vision out of University of Michigan Dearborn.
Alright, so let's get going. We would like first to go over exactly what autonomy means in regards to automobiles. There are 6 levels of autonomy in today's world, scaling from a level 0 to 5. We start with a human driver monitoring all driving environments. As we move to level 1, a driver assist system is in place, which is either steering or acceleration assist. Level 2 incorporates both steering and accelerating assist while keeping the driver still in charge of the vehicle. Level 3 has multiple ADAS systems in place where it performs all driving, however, the human must intervene when needed or necessary. As moving to high automation or level 4, a driver could expect much less human intervention as ADAS systems should know what to do to respond to a driving situation. Lastly, we have a level 5 or full automation. This is where human intervention is not needed and where all of the large automobile companies are trying to get to today, a fully autonomous vehicle.
As early as the 16th century, artist and inventor Leonardo da Vinci was contemplating the idea of an autonomous land vehicle. In 1500, da Vinci designed what many considered to be the first robot, a cart that relied on high-tension springs to be powered along a predetermined path by means of the steering being programmed at preset angles. This idea, which can be considered to be a precursor to the modern autonomous vehicles of today.
The Stanford cart was originally designed by Stanford engineering graduate student James Adams in 1961. Adams's goal was to study how feasible it would be to control a moon rover from Earth. This version of the cart was comprised of 4 bicycle wheels, electric motors, and a TV camera. After various tests, Adams concluded that the communication delay that existed with the steering commands made this design impractical, since the cart could not be properly controlled at speeds greater than 0.2 miles per hour. Little that Adams knew, his moon rover experiment would prove to yield the first true autonomous wheeled vehicle in just a few years later.
In 1963, graduate student Paul Brasted added an analog computer to the cart. This early computer improved the controllability of the cart by removing some of the communication delay previously discovered by Adams. This new scheme will consider future steering commands in future cart locations, and it did improve the speed at which the cart could be operated at, from 0.2 to 5 miles per hour. Further building on Adams' original design, executive officer of the Stanford Artificial Intelligence Laboratory, SAIL, Lester Ernest, modified the cart to navigate along a small road that surrounded the SAIL building. Due to the robust size of computers of the day, Lester and his colleague Rodney Schmidt accomplished this by transmitting the TV images to the SAIL computer, and from here a separate radio link was then used to send the control commands from the computer to the cart. Ultimately, Professor John McCarthy began working on the cart and modified it once again. With this version, no operator controlling the cart was needed, with the cart being programmed to follow a solid white line. At this stage in its lifespan, the cart became the world's first autonomous vehicle. In the late 70s, the cart again changed hands and was worked on by Hans Moravec and Victor Scheinman. The two modified the camera's mounting apparatus, which now allowed the camera to slide back and forth, greatly increasing the car's optical view. The main advantage with this modification was now the cart could remain stationary and multiple camera views could be achieved. As computer technology improved, so did the cart's performance. Relying on one of the most powerful mainframe computers of their day, the PDP-10, the computer's KL-10 processor was used to control a multi-ocular vision system that enabled the cart to successfully navigate a crowded classroom filled with chairs without human control. This task, which would have been considered impossible just a decade earlier, took approximately 5 hours to complete.